Back, everybody. So we're going to be dealing with still story problems, but this time they're going to be in their Intercept factored form. Again, I'm only going to do about one or two story problems. So let's start with the first one. In the game, Bouncing Babies, babies are thrown out of a building on fire. The baby's first bounce is represented by this quadratic formula, where f of x, remember that is just our fancy little letter for y, represents the height, and our x represents the distance from the building. All right, so let's go real quick, just so you guys can kind of see this. There is actually a game back in 1984. As you can see, it's a very old game. Oh, sorry, went too far. If I hit play, you're going to see the goal of the game is these babies are dropping and you're there to bounce them, and they bounce in these kind of quadratic forms. So that means in the background of the game, there's a quadratic equation that's being played so that they can actually bounce the baby however many times. And your goal is to get those babies into there. So let's jump to Desmos. First, going to type in our equation, which is negative x minus 3, parentheses x plus 3. And I can see that this is not really in frame, so I'm going to kind of minimize out. That actually helps because it also puts all these little tick marks to be 1, which I always like. And then we'll go ahead and see all the points that are important. We have this one up top, this one down below. So that's that first drop the baby does, and then they bounce from there. All right, so let's see what these the questions are asking us. I'm going to kind of do a little rough sketch so I can kind of remember. Remember that the y-axis here is the height. It's using the variable f of x, and it's done in meters. And then our x-axis, that's this one here, is represented by x, and it is the distance in feet. So when we talk about that, we'll talk about feet. So make sure we have our unit measurements, and then that is our distance. All right, so our very first question is, how high is the building window that the baby is being thrown from? So if we kind of remember, our quadratic kind of went like this, and then there was the other side, and we don't really care what's going on the other side. But if we go back to Desmos, you can kind of see this. Our important points were 0, 9, and 3, 0. So I'm going to come over here and put 0, 9, and then down here we had 3, 0. All right, so when we look at it, the baby started here and then it dropped out. So how high is the building window that it's being thrown from? We would say it is 9. That is our y value, so 9 meters. So this is up 9 meters. That's how big that building is. How far away must the fireman be to catch the baby before it hits the ground? So we want to be on that very first jump at this spot, which is 3 feet away. So he wants to be 3 feet away in order to catch that first bounce. All right, we go into a wonderful practical domain and range again. Remember range, we use our R values. I get up my wonderful thing. Range, since it represents the y's, that's going to be our f of x. So I'll put f of x in the middle. And then again, that means bottom to top. So the lowest we go is 0. That's the baby hitting the ground. And the highest it was 9 feet. And then they start to taper off from there. Our domain, that's our D. That is our, in this case, x value. So we'll go ahead and put x in there. And the closest it is at 0, that's when he's in the building, or the baby's in the building. And the furthest away on that first drop will be 3. So we put 3. So again, as you can see, these story problems, there's a multitude of questions they can ask. These are some sample questions. So there's our first example. Let's go ahead and jump to the second one. This one's an important one to be able to do in critical things. So you are interested in retrieving a souvenir. So there's an item at the bottom right next to a shipwreck. So we're looking at it. The shipwreck is located 90 feet below the water. So that's the depth I will have to make. You do not have diving equipment, so your dive is limited to this following equation. Again, f of x, that's our y, is the distance in feet. I will want to know that. And then x is the time in seconds under the water. So let's just assume you can hold your breath for this duration of the drive. It wants you to answer the following questions. So of course, the first thing I'm going to do is I'm going to grab this equation, f of x equals 0.5x parentheses x minus 90, and I'm going to plug it into Desmos. So once again, we have 0.05x, and x minus 90. And again, I can just see it looks like a linear, but what that just means is I need to really zoom out here. So I'm going to come over here and I'm going to just start zooming and playing so I can see where this U is. Kind of go in. Okay, so looking at this, it looks like the tick marks are going by 10. So that's 10, 20, 30, 40, 50. And it's going by tens on the Y's. This is important to know. Now keep in mind he's diving down. So this is where he's starting at. He's starting at 0, 0, and he's going, as you can see, down below. This is as far as he goes down, and then he is going to resurface. So that's what this U represents, and it's positive because we're actually diving below. So it's one of the rare times that we see a quadratic that's at the bottom, not the top part that's important. So we have those important points. Let's kind of just get our little rough sketch going. So switch back. We again have the Y, and this time I'm going to draw it where the X is up top because I want to be able to look at the bottom part of this U. I don't want to look at the top. So this is X. He's still represented as X, and he is also seconds. This is our time. Our Y in this case is F of X. And he is measured in feet. So get those in there so we know that. And then the U kind of started at 0, 0, I know, and then it kind of goes down and then up. That's kind of our little rough sketch. This is the part showing this. And then we have this important point. So I remember this one is at 0, 0. Let's go back and kind of look at it again. We have 90, 0, and then I have to get that one. So we'll go 90, 0 for this top one. And then this bottom one, which is called our minimum, is at 45, negative 101.25. This will just help us so we don't have to keep jumping back and forth onto their decimals. All right, what's the lowest you can dive? Well, this is the lowest we can go. That's our minimum. Remember that the X represents time, so that is seconds, if we want to write underneath there. And our Y, that's this, represents the how far you're going down. So that one is asking this part. What's the lowest I can dive? Well, I can dive to negative 101, or basically I can dive down 101.25 feet. So he's definitely a good diver. How long will it take you to reach? How long is talking about time. So our time was seconds, and that's 45. So we can get there in 45 seconds. So he's a really good diver, right? Will you be able to retrieve the souvenir? So if I can make it down to 101, remember that my souvenir up here is at 90. So 101 is definitely bigger than 90. I will definitely be able to reach that souvenir. I'm going to be able to get it. And then our domain, again, I'm going to go a D. X was used as the variable, so we'll keep with the variable that they use. It starts at 0. We never go back in time. And then we resurface at 90 seconds. So really the parts that we want are from 0 to 90. All right. Well, I hope that helps you. You have one more left in your notes. And again, the key is on my back desk. Thanks.